My goal is to solve this equation to find the values of x that make it true. On the right-hand side here, I have two logarithms, so I want to use a property of logarithms to combine those into a single logarithm. No action on the left. Log, I happen to be at base 10 here. As long as the log is the same everywhere, we're all good. On the right, I have two logs, same base, and they're added. So I can use property of logarithms that says I can rewrite this as a single logarithm where we're multiplying. So 3 times x plus 3. Now we're going to use the fact that logarithmic functions are one-to-one to say that if the logarithms of these two expressions are equal, then the two expressions must also be equal. That's the only way that we can have that equality. So 2x minus 1 equals, and I'll go ahead and distribute over here, 3 times x plus 3 times 3 is 9. Now I have just a regular old linear equation. So I'm going to use regular old linear equation techniques to solve it. I want to get all of the x's together on one side of the equation, so I'm going to subtract 2x on both sides. I'm going to get all the numbers together on the other side. I'm feeling coordinated today, so I'm going to do these two things at the same time. I'll subtract my 9 over to the left. And on the left, now I have negative 10 equals, and on the right, 3x minus 2x is 1x. Oh, so you might feel done at this point. X equals negative 10. Awesome. Except for we have a domain issue with logarithmic functions. The domain of a logarithmic function is positive values only. I can only take the logarithm of something that's positive. That doesn't mean I can automatically reject this, x equals negative 10. It doesn't mean that x isn't allowed to be negative. It means this whole expression isn't allowed to be negative, and this whole expression isn't allowed to be negative. So we still have to go back and check. Here we go. I'm going to try in my original equation before I did anything at all to it. I'm going to substitute x equals negative 10 in there. So I have log of 2 times negative 10 minus 1. And we'll do it all the way across. Negative 10 plus 3. And log of 3. Well, let's see. 2 times negative 10 is negative 20 minus 1 is negative 21. So on the left here, I'm trying to do log base 10 of negative 21. Oh, well, that's the problem. That's the domain issue, rearing its ugly head. I can't take a logarithm of a negative value. Its domain is positive values only, so that's not going to work. I only had one candidate for a solution. I worked my way all the way through, and x equals negative 10 is the only possible solution to this equation, and we just showed it's not a solution. It's extraneous. It doesn't work. So to answer the question that was asked by the original equation, what values of x make this equation true? There aren't any. I thought I had one, but in fact it doesn't work. So to answer the question asked by the equation, there isn't one. This equation has no solution. We thought we had one, turned out to be extraneous, so there is no solution to this equation.